All right, I was asked to do the top two problems on page 1 for 3-3, so I'm going to do those for you now and post those. So the first problem says you want to use method 2. So to use method 2 to find the derivative of the inverse, we want to first of all write this down as an inverse. So you change your y to an x, and you change your x's to y's. That's an inverse when the x and y's flip-flop. So that's my inverse. Now we want to find the solution to this when x is 2 without a calculator. So we're going to stick a 2 in here, and we're going to get y cubed plus 2y minus 1. And we want to find when that's 2. Now without a calculator, I'm going to tell you that they're going to usually make the numbers pretty simple. So you can just plug in a few numbers and try them. But I'm going to remind you how you do it for algebra 2 using synthetic division. You solve by getting any polynomial greater than 1 equal to 0. So you would subtract that 2 over here with this 3. And the things with this 3 has got p factors, and the only factors of 3 are 1 and 3. And the q factors are the coefficient in front of the leading term, and the q factors are 1. And then your possible factors of this, rational factors, are all of the p's divided by the q. So that's positive negative 1 over 1 and positive negative 3 over 1. Now I've already done this ahead of time, so I know 1 works. So I'm going to put 1 in there, and I get 1, 0, 2, and negative 3. When you do synthetic division, if you get 0 here, then 1 is a solution to the problem. So you always bring the first number under the line, number in the box times underneath, put under, add these two together. Number in the box times underneath, put it under here, add these two together. Number in the box times underneath, put it here, add these together. Since 0 works, that means that y equals 1 is a solution to my inverse problem here when x is 2. So what that tells me is I can take this 1 and I can go back up here and I can plug 1 in for this, and I'm going to, well, actually I'm going to do the derivative of this because I need to find the derivative of this function. So the derivative of x is 1. The derivative of y cubed is 3y squared dy dx, and I'm going to start abbreviating that y prime. And then the derivative of 2y is 2 dy dx. I'm going to make that y prime. And then I can factor out my common factor of y prime out of these two parts, and then get y prime is going to equal 1 over 3y squared plus 2. And so now I need to find my derivative. So my derivative of the inverse function when x is 2, because I'm doing it when x is 2, is going to equal this thing I just did when I plug this y equals 1 in for that. So when I plug y equals 1 in for that, I'm going to get 1 over 3 times 1 plus 2, which would be 1/5. That would be my solution. So 1/5 is the inverse derivative. Coming over here, this says this is a strictly monotonic function, which just means it's increasing or decreasing all the time. And since it starts lower and goes up, this is a constantly increasing function. And its derivatives are shown. So there's h of x and h prime of x, and it says let f of x be this function where f of x is equal to this. Well, what that means is that the derivative of f of x should equal the derivative of the inverse function of x. Because if these functions are equal, then these derivatives should be equal. And I'm supposed to find f prime of 4, which means I need to find the inverse function of h at 4. So what I need to do is I need to know that the derivative of the inverse function at 4 is going to equal 1 over h prime of h inverse of 4. So we just talked over here that in order to find an inverse, we flip-flop x and y. So basically, if I look right here, if I look at x and h of x, If I look at this and I know that if I plug in 2, I get out 4, what that means is if I plug in 4 for x, then my inverse function, remember you flip-flop them? If you flip-flop them, then your inverse would be 2. So what this means is the inverse h of x, when you plug 4 in, is going to give you 2 by flip-flopping these. So that means this is going to equal to 1 over h prime of 2. So what I need to do is go up here and find h prime at 2, which is 1/6. So this is going to be 1 over 1/6 because I'm plugging in that 1/6 for the inverse of h of 2. And then you flip and multiply by the reciprocal of this, and you would get that the derivative, oops, I put a -1 there, that should be a tick mark. The derivative of the inverse of h of x of 4 is equal to 6. Thanks, and I will see you later.